Mm. Good evening, ma'am. Good evening, ma'am.
Good evening. Okay, class. So what did we see in last class?
Ma'am, physical and chemical changes.
We saw physical and chemical changes. Okay. What else did we see? Only these two we saw?
Yes, ma'am.
Okay, fine.
Ma'am, I heard the lecture of the last class.
All right, all right. I'll share my screen. We saw different activities in last class.
Good evening, ma'am.
Good evening. Give me a minute, guys. All right. So in last class, we saw 4 experiments. Well, the third experiment is about how we test the presence of carbon dioxide. By passing through carbon dioxide air through lime water and it turns milky, this shows that carbon dioxide is present. And these are the chemical reactions that we saw. So basically, when carbon dioxide is passed through lime water, calcium carbonate is formed, which makes the lime water milky. So the turning of lime water into milky is known as, it's one of the standard tests of carbon dioxide, which we'll be seeing in the upcoming classes, like in detail and all. All right. And we also saw the process of rusting, right? So copper, you can see basically what did we see? By putting a nail inside it, rust is being formed and all, we saw that. So copper was deposited in the shaving blade or the iron needle. So we saw that in the other activity. So the change in which one or more new substances is formed is known as chemical changes or chemical reactions. All right. So chemical changes and chemical reactions are very important in our life. So all new substances are formed as a result of the chemical changes. Okay. For example, digestion of food in our body, for example, all that is a chemical change. Ripening of fruits is a chemical change. Fermentation of grapes is a chemical change. So all this has happened due to a series of chemical changes. So medicine is the end product of a chain of chemical reactions. Again, without chemical reactions, medicines won't be formed today. So useful new materials such as plastic and detergents are all produced by chemical reactions. So indeed, every material yeah, tell me.
Ma'am, can you please show the example 3, because in previous class I have a network problem, so I leave that meeting. Ma'am, only example 3 I left.
This one, it's not example, it's
Yes,
experiment 3. So the reaction is you take vinegar, and in vinegar you're adding, in a test tube you're adding vinegar and you're adding baking soda to it. Okay. And when you're adding that, you're having a hissing sound along with bubbles are being formed. You're going to attach it to a glass tube, which is the red tube you can see over here. So glass tube to another test tube that consists of lime water. So the air that is coming here is let to pass through this glass tube over here. After a few times or few minutes, this lime water turns into milky white, a milky solution. This shows that the presence of carbon dioxide is there, or carbon dioxide is released over here. Okay. And this white substance that is being formed, which makes the lime water milky, is known as calcium carbonate, which gives you the chemical reaction. Vinegar, which is nothing but acetic acid, plus baking soda, produces carbon dioxide and other substances. When passed through lime water, that is CaOH twice, calcium carbonate is formed. This is the reaction. Do you understand?
yes, ma'am.
Okay. So we have seen that one or more new substances are produced in a chemical change. In addition to the new products, there are also other properties of a chemical reaction. So you clearly know in a chemical reaction, firstly, a new substance or substances are formed. Secondly, what happens? Heat, light, or other radiation it will either be absorbed or it will be produced. As you can see over here, the hissing sound is produced and also the test tube becomes a little bit of, it gives a little bit of warmth. We saw another reaction over here. It gives you a brilliant white flame, which is also heat again. So radiation, white light is a radiation. So heat or radiation is being formed. That's the second property. Third is sound. So you can see over here, a hissing sound is being produced. Then you have change in smell. Smell will change. Then you have change in color. We saw over here, the blue solution turns green. Formation of gas. Here carbon dioxide is being formed, which is a gas. Okay, so for now we saw an example, or we saw an experiment of burning of the magnesium ribbon, which is a chemical change. So and there's also other examples like burning of coal, wood, or leaf. All this is a chemical change. So in fact, burning of any substance is a chemical change. Burning is always accompanied by production of heat. Okay, so explosion of fireworks, that is also a chemical change. So you know that the explosion also produces heat and light and sound and unpleasant gases that pollute the atmosphere. So all these are chemical changes. So you must have noticed that the slice of an apple, after a few minutes, it becomes brown in color if not consumed immediately. It's because it is coming in exposure with the oxygen in the atmosphere. Right, so the change in color has a formation of new substances. So now we're going to see about a protective layer of the earth. Okay, so we're going to talk about a protective shield. Okay, so have you all heard of the term ozone layer?
Yes, ma'am.
What is this ozone layer?
Ma'am, does it prevent UV ultraviolet radiation?
Very good. It protects us from the direct ultraviolet radiations produced by the
Sun.
sun. So basically, it protects us from the harmful from the sun. So the ozone, what it does, it will absorb. It will absorb these UV radiations, and what they will do is they'll break down this UV to oxygen. It will absorb and it will break the UV radiations into oxygen. All right, so oxygen is different from ozone. Okay, so if ultraviolet radiation, oxygen is O1, O2, or O3?
O2.
O2 is oxygen. O3 is ozone. Okay, so what happens? This ozone, look at the diagram very carefully. So this UV radiation, which is coming down, it is touching the O3. It is absorbed over here. This O3, it will break into O2 plus O1. Okay, this is how it will break down. That is why we are protected from these O3 variations. Okay, it will break down into oxygen. All right. So if ultraviolet radiations were not observed by the ozone, it will reach the Earth's surface and it will cause harm to other life forms. It will cause cancer and all that. So ozone acts as a natural shield against this radiation. All right. Please note down whatever is there in this page. Tell me when you're done.
Ma'am, what is O1?
O1 is just another oxygen with one atom. That's it. O1 is also known as atomic oxygen. So what will happen? Like so many like O2 molecules will be formed, right? Like what do you say? Another division will be there, O2, O1. These will join and they'll become O2 again.
Ma'am, I have a question.
Yeah, tell me now.
Ma'am, in the Russia-Ukraine war, many missiles are blasting. So, in the blasting of missiles, is there any chemical reaction or radiation is produced?
Yeah, definitely it will be produced. So basically, this ozone layer, it's a natural shield. Okay, you have heard about the term global warming, right?
Yes, ma'am.
Yeah, so all the pollutions that we do, all the, now for example, you're taking a small glass container, okay, or you're taking a balloon, okay, there's only a particular amount of air it can hold. So if you put excess amount of air, it will burst, right? Similarly, there's only a particular number of good air this ozone layer can tolerate. So all this pollution and carbon dioxide that we're using, be it missiles or be it anything, again, what are they doing? They are firing. Firing again causes pollution. So it's not only the missiles or the military weapons that causes pollution. It's also us human beings. We're using bus transport, cars, and using polluting bikes and all that. So all these add on to the depletion of the ozone. So basically, global warming is depleting the ozone layer. So once if the ozone layer is all depleted, then the human race will be no more. Okay, so it's not only the missiles that is causing radiation that is harmful, but also us human beings. All right.
Yes, ma'am.
Done, ma'am. Okay.
Yes,
Tell me when you all are
ma'am.
done.
Done.
Who is left?
Mummy, mama, I'm done.
Okay.
Mom, done.
Okay. All right. Okay. So we'll like see a small clip about the ozone layer depletion.
What if I told you I can give you an intern who can work 24/7 without a break, and that too?
Friends, today's lesson is ozone layer, and we will learn about how to produce ozone and its depletion. As we discussed the ozone layer in the last topic, which was the layer of atmosphere. So, in this topic, we will focus on the ozone layer. The ozone layer is a deep layer in the stratosphere, encircling the Earth, that has large amounts of ozone in it. Ozone is basically an allotrope of oxygen, which has 3 atoms of oxygen. The ozone absorbs the portion of UV light called UVB and UVA band of ultraviolet radiation, with wavelengths from 280 to 320 nanometers, produced by the sun. UVB is a kind of ultraviolet light from the sun and sun lamps that has several harmful effects. UVB is particularly effective at damaging DNA. It is a cause of melanoma and other types of skin cancer. It is always important to protect oneself against UVB, even in the absence of ozone depletion, by wearing hats, sunglasses, and sunscreen. However, these precautions will become more important as ozone depletion worsens. Let's understand how to absorb UV light and produce ozone in this layer. Oxygen gas has 2 molecules of oxygen. It is present in the atmosphere. High-energy UV light collides with the oxygen molecule, causing it to split into 2 oxygen atoms. These atoms are unstable, and they prefer being bound to something else, and then the free oxygen atoms smash into other molecules of oxygen, forming ozone. Remember, one atom plus oxygen gas made ozone. The ozone is destroyed in the process that protects us from UV rays emitted by the sun. When ozone, O3, absorbs UV light, it will split the molecule into one free oxygen atom and one molecule of oxygen gas. O3, ozone, O1, atom, plus O2, oxygen gas. Ozone is valuable to us. But, ozone layer is depleting day by day. We are ignoring the major effects of ozone layer depletion: chlorofluorocarbons, CFCs, chemicals found mainly in spray, aerosols heavily used by industrialized nations for much of the past 50 years, are the primary culprits in ozone layer breakdown. When CFCs reach the upper atmosphere, they are exposed to ultraviolet rays, which causes them to break down into substances that include chlorine. The chlorine reacts with the oxygen atoms.
I want you all to concentrate on the video. It's not just for the graphics. So I'll ask you questions from this video. Okay. So once I'm done with the video, tell me if you want me to play it again. I'll be asking you all questions. So please listen carefully.
Ozone, and rips apart the ozone molecule. Chlorine plus ozone, chlorine monoxide plus oxygen gas. This would not be a huge problem, except for one thing: chlorine monoxide will collide with free oxygen atoms. This oxygen atom will break apart the chlorine monoxide, and releasing the chlorine atom back into the stratosphere to damage more ozone. This reaction happens over and over again, allowing one chlorine atom to destroy many ozone molecules.
Did you understand?
Yes, ma'am.
Do you want me to play it again? Anyone wants me to play it again? All right. Anubhav, tell me what are CFCs? What are CFCs? They told in the video something called CFC. What is CFC? Ritvik?
Ma'am, they are chlorofluorocarbons.
Chlorofluorocarbons. Very good. What are these chlorofluorocarbons? Do you have any idea?
Ma'am, they are harmful gases which are not fit for the ozone layer.
Okay, very good. So basically, these chlorofluorocarbons are normally produced by the pollutants that we used to, we do it by using our vehicles and everything. But normally they are through sprays, sprays, right? Perfume spray and all these foams, all packaging materials, all these are only CFCs. All right. What happened, Anubhav? We didn't concentrate. Okay, Anubhav, tell me how many molecules does ozone have?
Ma'am, 3.
And what is O with a single atom known as?
Ma'am, can you repeat again?
What is O1?
Ma'am, it is one atom of oxygen, ma'am.
There's another name that I told you. What is it? Atomic oxygen. Okay.
Okay, ma'am.
All right. And Leshita? Yeah. Leshita, tell me, with, this O3 is protecting us. But apart from that, what are the other ways of protecting ourselves from the ozone? Rishita? Rishita, am I audible to you?
Yes, ma'am.
Yeah, tell me. What are the other ways of protecting us from the UV or from the ozone? How will you protect yourself?
Ma'am, sunscreen, sunglasses.
Very good. Wearing sunglasses, hats. All right, fine. Okay, so going back to the lesson. So these are the different ways to protect ourselves from the ozone. So ozone is a very important shield to protect us, but at the same time, we should also protect ourselves from them. All right. So now we're going to see in detail about rusting of iron.
Ma'am,
Yeah, tell me, Ra.
ma'am, actually, I was unable to join the class due to like some issues in the in my tablet, so that
Not an issue, not an issue. You can refer the lecture anytime. Okay.
okay, ma'am.
Yeah. So now I already spoke about how rusting and everything is done. So we're going to go back to that topic. So this one change that affects iron particles and it slowly destroys the iron. Okay, so since iron is used to make, now for example, it's used to make many materials like bridges, ships, cars, trucks, bodies, and many articles are all made by iron. And all these big cars and all, it's like sold in lakhs. Bridges and all, it costs 7 crores sometimes. So all of these are being wasted because of rusting. So the process of rusting, so rusting is nothing but it's the eating up of iron, right? So the process of rusting can be present. I'm giving you the equation for rusting. So you're taking iron or Fe, okay? It comes in contact with oxygen that is in the air and all the moisture, so water, that is H2O, which will give you rust or iron oxide, which is Fe2O3. Okay, so for rusting, you need the presence of both oxygen and water or water vapor. So in fact, if the content of moisture in the air is high, which means that it is more humid, then rusting will become faster. So more the humidity, more the moisture, and more the rusting. All right. So how do we prevent this rusting? We're spending so much money on iron. So how do we prevent it? So basically, if this is the iron, this iron is coming in contact with the oxygen and water, right? So we need a protective shield or we need a protective layer to prevent this iron from coming in contact with the air and the water. Only then the rusting can be prevented. So prevention of iron particles from coming in contact with oxygen or water or both. So one simple way is by applying a coat of paint or grease. So when you're covering it with paint or grease, it cannot come in contact with air or water. So in fact, these coat should be applied regularly to prevent another rusting. So another way is to deposit a layer of metal or you can use this. This is one of the method. Second method is you can put a metal deposit, which is known as chromium. You can use chromium or zinc on top of iron. Okay. So this process, so you can either use paint or grease, or you can coat them with another metal, which is chromium or zinc. Okay. This process of depositing chromium or not chromium, this process of depositing zinc to prevent iron from rusting is known as galvanization. The method of protecting iron from rusting by coating it with zinc is known as galvanization. Hello? Hello?
Yes, ma'am.
Yes,
Yes, sir. No, sir, nobody's waiting. No, I admitted her 10-15 minutes back itself. Yeah, sir. Okay, sir. Nice. All right. So this is through galvanization is the method that is used for coating it with zinc. All right. So now iron pipes and all. Iron pipes that we use at home for carrying water. All these are, you can see the shining, no, even iron pipes, taps and all. Taps and all are shining outside. Why? Because they are iron that is coated with zinc. Okay, because they have continuous exposure, water is happening, right? So it is all galvanized. So the iron pipes that we use at home are galvanized to prevent it from rusting. So you know that the ships are also made up of iron, and a part of them will remain underwater, right? So on the part above water also, the water drops will keep on coming, right? Because of the waves and all. So all of them are galvanized. Moreover, water of the sea also, it contains many salt also. So salt water makes the rust formation even more faster. So therefore, ships suffer a lot of damage from rusting in spite of being painted also. So much so that the fraction of ship's iron has to be replaced every year. So because they're now this is coming in contact. Now a paint also, for example, you must have noticed after you paint a metal, they worn out after a year or something, you can see patches of paint, right? So even they wear out. Okay, they can only protect for some extent, right? So now they cannot continuously be protecting us. Now, for example, you're taking a medicine for fever. Only for that period of time that medicine will help. That medicine which you had 1 year back, it is not going to help you later on. You're going to have another dose of medicine you should have. Similarly, that protective layer, it can only protect the iron only for a particular period of time. Now, if you take a ship is being continuously in contact with salt water, right? So apart from salt, it has to continuously be underwater. You can't do anything, right? So rusting is even more faster because it is being inside water itself. So every year they're going to change the iron of the ship is changed every year, which will cost lakhs and lakhs. So every year our country is spending that much money on the loss of the ships. Okay, so this is rusting for y'all. So now I'll just write all the negativities of rusting.
Ma'am, from the starting, this is what is the notes or more notes is there?
We learned about ozone layer. These are the other notes. Maybe you can note this down, and I'll show you that page. You can note that down.
Okay, ma'am.
Okay, guys, note it down. Tell me when you're done. One minute, guys. And another term, people. So basically, another word for rusting. In exam, they might ask you this word also. Rusting is basically what? It is the eating away of the metal layer, or what do you say? Wasting away the metal layer due to presence of water and air, that is oxygen, is known as rusting. Another term is, this is also known as corrosion. Okay, it is a slow destruction of the materials.
Ma'am,
Tell me.
ma'am, what's the third word beside moisture? I mean, beside the word beside moisture, right side.
It's rusting now. Don't write these disadvantages now. Okay, just pause all of y'all. So disadvantages. So this is just basically a summary of whatever we saw. So obviously rusting will provide a dull appearance. You'll nicely polish, nicely shine and keep the iron. And all this rusting, it will happen in few hours and it will provide a very dull appearance. Shining, luster and all will go away. Second thing, it will lose its lifespan. If an iron is nice, strong and supportive, after rusting, it will be eaten away, it will break down. So its lifespan will reduce. The metal or the iron's lifespan will reduce. Second, you need to replace it by painting it or by galvanization, and you need to protect it every year. So there is a lot of waste of money that is happening because of rusting. So these three are the main disadvantages of rusting. So you can note that also down. Tell me when all of you are done with your name.
Ma'am,
Yeah.
ma'am, what you have written, ma'am, in the wasting away of the metal layer under it, what is, ma'am, corrosion or what is?
Yeah, corrosion. Corrosion is another term that is used for rusting.
Okay, ma'am.
Hello.
Ma'am,
No, so I told I'll talk to my parents and I'll get back to you. Please give me some time.
Done, ma'am.
Yeah, sure. So thank you. Yeah. Okay, Anubhav is done.
yes, ma'am. Done, ma'am.
Okay.
Mom, shouldn't we write disadvantages?
Yeah, right, disadvantages also.
Completed, ma'am. Ma'am, can you put the previous slide if everyone completed?
Yeah, if anyone's left, is anyone left to complete this page?
No, ma'am.
Please note it down quickly. Da. Are you done, Kritika?
Ma'am, I'm writing protective shield.
Yeah.
Complete.
Okay. So again, we'll see a clip for rusting.
क्या दूसरे मेडिसिन के साथ श्राया का हेयर लॉस ट्रीटमेंट ले सकते हैं? वेल, इन मोस्ट
and how we can prevent it.
Again, concentrate, guys. Question will be asked to WeXL. Please make notes of important things he's saying also.
In this video, we're going to look at corrosion, and in particular at why things rust and how we can prevent it. Corrosion is a general term that refers to the process by which metals are slowly broken down by reacting with substances in their environment. One example of this is rusting, which is where iron reacts with oxygen and water from the environment to form hydrated iron oxide, which is more commonly known as rust. If we think about what's happening here at the atomic level, the iron atoms in our original block of metal are each losing 3 electrons to become iron 3+ ions. And at the same time, the 2 oxygen atoms in each oxygen molecule are gaining 2 electrons, so a total of 4 electrons, to become oxygen 2- ions. So the iron is being oxidized because it lost electrons, while the oxygen is being reduced because it's gaining electrons. And this means that the overall reaction is a redox reaction, because both oxidation and reduction are taking place in the same reaction. The next thing we need to cover are the conditions that are required for rusting to take place. We said earlier that rusting involves iron reacting with oxygen and water from the environment. So both of these have to be present for rusting to take place. To see this in practice, let's imagine 3 test tubes, each one with an iron nail in it. The first test tube contains water but no oxygen. This is because the water has been boiled to remove any of the oxygen that was previously dissolved in it. And this layer of oil at the top stops any new oxygen that's in the air from dissolving into the water. The second test tube contains air, and so oxygen, but no water. And this is achieved by having the calcium chloride at the bottom, which will remove any water vapor from the air. And then the final test tube contains both air, so oxygen, and water. So if we now left these test tubes for a while, only this nail in the last tube would rust, because it's the only one that contains both oxygen and water. One important thing to understand with corrosion is that it's only the surface of a metal that corrodes. This is because only the surface is exposed to substances in the environment, like water and oxygen. When iron rusts, though, the rust that forms at the surface gradually flakes off, revealing new metal underneath. This means that the next layer can also rust, and over time that bit will fall away as well. So if left long enough, the entire chunk of iron can break down until there's nothing left. In contrast, when metals like aluminium corrode, it's only the surface atoms that are affected. This is because when the top layer of aluminium atoms is oxidized to form aluminium oxide, they effectively form a protective layer around the piece of aluminium, which protects the rest of the metal from the environment. The last thing we need to look at is how we can prevent iron from rusting. Generally speaking, we can split the methods into two main categories: barrier methods and sacrificial methods. The barrier methods work by preventing the oxygen and water from ever touching the iron, so that rusting can't take place. And there are three main types to know. One is to paint it, which works well for really big pieces of iron, like the side of a ship. The second is to oil or grease it, which is necessary if the object has moving parts like a bike chain. And the third type of barrier protection is electroplating, which is kind of complicated, but basically involves using electrolysis to cover the iron in a thin layer of another metal, which will protect the iron underneath. The other option is called the sacrificial method. This involves adding a more reactive metal, like aluminium or zinc, to the iron. This means that if the object gets exposed to oxygen, the more reactive metal will be oxidized instead of the iron, and so the iron won't rust. An example that uses both of these methods is galvanizing. This involves coating the iron object in a layer of zinc, which is effectively the barrier method, because it's forming a protective coating around the entire nail. However, if the zinc coating gets scratched, and the underlying iron gets exposed, the zinc will still react with any oxygen that goes near the nail, because the zinc is so much more reactive. So it's actually an example of the sacrificial method as well. Anyway, that's everything for this video. So if you enjoyed it, then...
Did you understand?
Ma'am, I have a doubt.
Yeah, tell me that.
Ma'am, do rusting happen only with iron or with other metals also?
It happens with other metals also, but mostly with iron, because the only metal that is used for majority of the manufacturing things, weight, bridges, cars, any machinery, iron only is used, not any other metal. So it's iron.
Ma'am, why only iron?
Because it is a very reactive metal. Different metals have different reactive properties. So iron is the one of the reactive metals that only that metal, when it comes in contact with, now for example, you're wearing a gold jewelry. So have you seen it rust anytime?
No, ma'am.
Yeah, so every metal has its own properties. So one of the properties iron is to rust. None of the other metals have this property.
Okay.
Okay, so there are actually no other metals that rust. It's only iron.
Okay, ma'am. Just because like iron is also metal and other metals are also metals, like for example copper and all, why don't they rust? I just couldn't.
No, come again.
Like, ma'am, because like always copper is we usually put copper type of things in water. We store water in copper and all. So why won't they rust? Like I just had it out.
Yeah, they don't rust because they are not much reactive. Gold and all are like, what do you say? Now zinc and all, when you see, why are you quoting them? Because they are reactive metals. Okay, so iron is a very less reactive metal that which is very sensitive when they come in contact with air or water, they start rusting. Whereas gold and all, and zinc and all, it costs you more. Actually, they're more costly, and they are compared to iron, they are more costly, and also they are more reactive metals.
Yes, ma'am.
Yeah.
Like gold and all, gold, silver are a bit costly.
Yeah. All right. Anybody else who has a doubt? Okay. Anubhav, tell me, what is galvanization?
Ma'am, it is a process which protects the iron from rusting.
Yeah. What? How do you protect it?
Ma'am, it is happened by a zinc coating, which is a barrier method, and the underlining of the zinc will react with oxygen. That will a sacrifice method.
Okay. Very good. Fine. All right. Trithvik, tell me. Wait, let me think of a question for you. Okay. Tell me true or false. So when an ion is exposed to oxygen and water, the whole ion starts rusting.
Ma'am, true. It gets rusted.
The whole ion will start getting rusted.
Ma'am, because it's exposed right to water and oxygen.
Okay, so it's actually not the whole metal, it's only the surface of the metal that will be exposed. So only the surface of the metal will erode,
Yes.
not the whole metal. Okay. All right. Leshita, so when this ion comes in contact with oxygen and water, what is the substance that is being formed?
Ma'am, rust.
What is the chemical name for rust?
Ma'am, iron oxide.
Iron oxide, very good. Okay. Okay, Sai Kritika, tell me, so this whole reaction of iron coming in contact with oxygen water, producing iron oxide, is known as a dash reaction. What is it?
Reaction. Chemical reaction.
No. Starts with R.
Rusting, ma'am.
No. Anybody else who knows the answer can raise your hand.
Ma'am, can you please repeat the question?
The whole reaction of iron coming in contact with water and air in order to produce iron oxide is known as the dash reaction.
Ma'am, rust.
Can I tell, ma'am?
Tell me.
Ma'am, a redox reaction.
Redox reaction, very good. It's a redox reaction. All right. Why it's called a redox reaction means because first iron is nothing but Fe. Okay. So when Fe, when it comes with contact with oxygen and water, it is losing 3 electrons, and the oxygen is reduced. Oxygen O2 is becoming 2O2 minus. Since it's being reduced, it's known as a redox reaction. Okay, so when iron is coming in contact with oxygen, it's becoming Fe3 plus 3 electrons. So iron is getting oxidized. Okay, iron is getting oxidized and O is becoming reduced. So it's known as oxidized, you're getting OX, reduced, you're getting RAD. That's why it's known as redox reaction. Am I clear?
Yes.
Yes, ma'am.
Just a minute, guys. Fine. That's it for today. We'll see in our next class. Okay. And Monday, there'll be no class since I'm going out of station for some family function. Your next class will be on Wednesday. All right.
Okay,
Ma'am,
ma'am.
for 2 days no classes.
Sorry.
Ma'am, for Monday and Tuesday no classes.
Tuesday is not, I'm not scheduled for that day, no. So I take only in alternate days, right? So Monday alone you'll not be having, you'll be having a next class on Wednesday. Prepare for your Sunday's test. It will be mostly based on this lesson. Sunday you'll be having a test. All right.
Okay, ma'am.
Okay, thank you. Bye.
Bye, ma'am.